Hello everybody and welcome to another episode of Still Diffusion for professional creatives. Today we'll be taking a look at loops. What are they and how we can use them to automate stuff inside of ComfyUI. I'll be seeing a couple of examples on how we can use these two tiny nodes in order to automate upscaling, for example, or finding out, like in this case, how many faces there are in an image and then creating a mask for each of those faces, all automatically without actually doing any calculations beforehand or having to create a multi-stage workflow that accounts for all of these loops that it should go through. Same as always, you will be able to find this workflow in the description below, as well as any other custom nodes or models you might need. You will also find some timestamps in the description, just in case you want to jump ahead. So now, let's dive right into it. So first of all, what is a loop? A loop is something that happens and is repeated between a loop start and a loop end node. It gets repeated an n amount of times that is defined here in the total input box, and every time it runs, every time it loops, something different happens. Now, what changes in a loop? Well, you define it. And what changes in the loop is defined by the values that you decide to pass into it. Now, as you can see here, we have one input with initial value 1. But as soon as it gets populated, for example, let's say with a string, another possible input pops up. So you can populate more than one input. On the output side, we have flow. Flow defines how a loop flows, and it should always be connected from a for loop start to a for loop end node. For now, let's forget about what happens inside of here, and let's take a look at the outputs for the for loop end node. Right now, we have a value 1, and that is what gets out of this loop. But how do we define what we want to get out of this loop? Well, while anything could be the input or the output of a loop, since we are working with generative AI, it's most likely that the input for value 1 and the output for value 1 will always be an image. It doesn't have to be, but most of the times, let's be real, it's going to be. So let's erase this string node, for example, and let's use this load image node instead as the initial value 1. Now, if we connect this value 1 to initial value 1 and output a preview image and run this workflow, we will see that the image gets in, the image gets out after one loop. If we increase the number of executions for the loop, nothing really changes, it just goes through one more loops, but there's no operation here. The image that goes in is the same as the image that goes out. But what if we wanted to do some operations to the image? What if we wanted to change that iteratively? Well, we can absolutely do that, and there's some different ways in which we can do that. For example, let's say that for each loop, we want to upscale an image by 1.5 per. Before connecting the value 1 in the loop to the loop end, we want to pass this on, and if we want to make sure that something is happening, well, let's do that by also appending a get image size and a show any nodes to the initial image and the final image, and let's run it again, and we will see that the initial width is 1024 and the final width is 2304. So what happened here is that the image got upscaled 2 times at 1.5 per each time that the loop has executed. And this at its core is what a loop does. It can be as simple as this or as complex as you want, but it simply executes something defined in between the start and the end an n number of times according to specific instructions. Now, this is a very easy example and not a very useful one. So let's see a more complex one, a more useful one. Let's say I have the same image loaded here and I want to automate upscaling. In this case, a simple Langsos upscaling without any actual case sampler doing the heavy lifting for us. And I want to do that X amount of times without doing any math beforehand on how many times I have to do that, knowing only 3 things: the initial resolution of the image in terms of megapixels, the target resolution of the image that I want to achieve, and the scale factor that I want to apply for every single iteration. If we append a show any node here and run it again, we will see that right now the image is around 1 megapixel. It's 1,048,566 pixels, but I want to get up to 5 megapixels. So that's 5 million pixels. But I don't want to go straight from 1 to 5 because I'm worried about losing details, for example. What I want to do instead is rescale the image each time by a factor of 1.2 per. Now, how do I do that? Well, first of all, I need to set the amount of iterations that I need to run in order to get from 1 megapixels to 5 megapixels by scaling the image 1.2 times per each time that the loop runs. And since the last time I did proper math was probably 15 years ago, I asked GPT to write down a formula for me, and this is what it came up with. That it's all expressed here. So we are calculating the base resolution, the target resolution, then we are calculating the ratio between the target resolution and the original resolution, and then we are doing some math stuff with logarithms, and that gives us 9 iterations. Now this is an approximation, and this is a very weird case, and that's because one of the variables that's defined in order to find the number of iterations is in itself a variable that is decided inside of the loop. So there's no definite answer to how many loops we need to go through. There's only an approximation, and you also cannot really have half loops. You can only have integer loops, so sometimes it overshoots by 1. But that's a non-issue because inside of the loop, what happens is that we are passing, for starters, the original image and the total number of loops calculated in the beginning. And inside of the loop, we are using that same value 1, which is the image that gets passed through and manipulated throughout the loop in order to get its size, multiply the width and height in order to get the megapixel value. We then check if at any point during the loop, the resolution that we are getting is higher or equal to the target resolution, and if it's not, we are scaling once again 1.2 times per, and if it is, we have a fallback for one last rescaling at 1 per, which leaves it at the same resolution that it just checked. And this upscaling is managed by the upscale image by node that uses the image that's going through the loop and the scale by factor, which is applied by this equals or is bigger than logic. And it's either 1.2 per or 1 per. Once the number of iteration runs out, the loop ends, and we get an image that is sized at 6 megapixels in this case. And since 6 is bigger or equals to the target resolution of 5 megapixels, that's exactly what we wanted. If we use, for example, a different value of scale factor, in this example 1.5 per, we will get a different resolution, in this case 5 megapixels, which is still higher or equals to the target of 5 megapixels that we had, but it's different because it runs through a different number of iterations, in this case 4 iterations, and since the multiplication logic is different, it's going to yield a different result in terms of resolution. But still, it's correct. It's still a higher number than 5, which is the target, and it's the closest one that it could produce. If you want, like in this case, to switch the upscale image by node with an ultimate as the upscale node, you can absolutely do that. The logic it follows is the same. The image that comes in is from value 1 in the for loop start node, and the image that comes out of the ultimate as the upscale node goes into the for loop and initial value 1 input. And as you can see here, I adjusted the target resolution to 2 megapixels because this is a diffusion process, and of course it takes longer than just resizing an image. And the final resolution is 2.35 megapixels, which is equal or higher than the target resolution. It's the closest value to the target resolution that we wanted. Well, let's now take a look at something a bit more complex. Let's say we wanted to have an user input an image, but we don't know how many faces there are in that image. We don't know how many people there are in that image, but we want to always be able to find the maximum amount of people that a face parser model, like in this case, YOLO face, can actually find, and then mask those faces. Well, how do we do that? Without using loops, you would have needed a couple of things. You would have needed the user to input however many faces there were in the image, for example, and you would have to create a node structure that accounted for that number of faces. With loops, it can all be automated. In this case, of course, we only have one image. And if we take a look at the bbox detect face parsing node, it's outputting a count of 1 faces. If we take, for example, this image that has multiple faces in it, we will see that the count now is 12. Now, if we know that there are 12 faces and we want to do the same operation for that amount of faces, what is that number? Well, that's the number of iterations the loop has to go through. So we can pass that information onto the loop and set a total amount of loops for that same amount of faces, so that the masking process happens for every single face there is. We have a node here that applies the face parsing logic to each item individually. All the items are all the faces listed as arrays starting at 0 and going up until, in this case, 11, because 11 equals 12 if you start counting at 0. And how can we adjust that value for each iteration that happens? Well, by using the index output of the for loop start node. In this case, the index will be outputting a number that goes from 0 to 11, and that is the iteration of the loop that it's on. So for each loop that it goes through, a new face will be parsed and added to an empty mask. And if we run the process, we will see that each time a new mask gets added to the empty canvas. And that will keep on happening until the last face that the parser has found has been implemented onto this canvas. And as a for loop and output, we have the masks for all the faces that are present in the image, or at least all the faces that the parser can find. And once again, this is the bare bones structure of a loop that employs mask faces. This is useful, for example, if you wanted to apply a face swapping to each of these faces individually, either with just one target face or a list of faces, with each faces going through the process one time with an incremental array, for example. Or let's say you wanted to do some iterative in-painting process for all faces, or you wanted to erase an X number of objects that are present in a picture, but you don't know how many there are. The list goes on and on and on, really. It's just a matter of asking yourself one question, and that question is there something that can be automatically done X number of times the same way, just changing one thing during the process? And well, one or more things, because the loop accepts more than one different input. And the possibilities are really endless. Let's say we have this starting image of 4 mushrooms in a forest. Now, I don't really have a way, well, except for maybe an LLM node, to know the exact number of mushrooms in a picture, but I mean, I have eyes, so I can just say, for good measure, that I want to iterate this 4 times total, and I want to get rid of these mushrooms by iterative in painting. So I can have a grounding dynamically segment logic targeting mushrooms, and it may happen in just 1 iterations or 4 iterations, but it's gonna find each mushroom and in-paint into them. And as you can see here in the final result, all the mushrooms have been taken care of without actually caring too much about how many times the grounding dynamically segment logic would need in order to find all the mushrooms. The image comes into the loop, goes into the grounding dynamically segment node, the SAM finds a mushroom, or more than one, I don't know, because I don't know what happens in here, and then in-paints over that mask. And then it goes on again and again and again and again 4 different times, and if it doesn't find any mushrooms, well, it's not going to do anything because the mask is going to be empty. But that's not an issue for me, because I just want to know that all the mushrooms will be gone. So, all in all, some fun with loops. I really like using them, and I think they open up some doors for automation in ways that I find very much enjoyable. It is a way sleeker way of doing things, I think, and I hope you will find it useful too. If you like this video, remember to leave a like and subscribe. My name is Andrea Baioni. You can find me on Instagram at reasonabushi or on the web at andreabaioni.com, and same as always, I will be seeing you next week.